how to make sure an apple doesn't fry.
Yeah. We just had to go hard in the middle and then straight. Okay, so we're going to do with 3 topics. One is going to be familiar, and that's going to be today. We're going to look at integrals of logarithmic and exponential functions, so the antiderivative e to the u and the antiderivative 1 over u. And so this will kind of ring a familiar bell for you. And then the second topic is going to be something called slope fields, which is very new, but it is nice and easy and straightforward. Okay? And then the third topic will be something called separable equations. And those are really the last topics you need in order to handle anything that you would see on the AP exam. So those are the 3 pieces. And after we do that, then we'll be able to begin our large review. So I anticipate this only taking until, at the very, very latest, I would say we'd be testing next week, Friday. Okay? But I would say we could probably get it by next week, Thursday or Wednesday or something like that. We'll see where we get. We're not under a huge time crunch. You guys have done a good job of maintaining good pace here, so we've got good time. So let's do the basics. What do you think is the antiderivative of e to the u? Good. And what do you think is the antiderivative of 1 over u? Let's think about it differently. What do you take the derivative of to get 1 over x? So the antiderivative is natural log. Now, here's the tricky thing. You can't take the natural log of 0, and you can't take the natural log of a negative. So it's the natural log of the absolute value of u. You have to make sure that u is positive. So it's the absolute value of u plus c. I could give a little bit more in-depth analysis onto that, but I don't think it would really matter a whole lot. Okay? So we'll just leave it. You okay with the absolute value piece? Good. So let's give this a shot. Okay? Determine the following. We want to go the integral of e to the 4x. Now, it's never as simple as just e to the 4x. We do have to use substitution in this situation. So what do you think that u is? Good. U is 4x. So what is du? 4dx. Do I have a 4dx? No. So I multiply by. So 1/4 du is equal to dx. All right. So my new integral is 1/4 integral e to the u du. Oh, Miss Morgan, remember yesterday? We talked about what that thing means, didn't we?
Yeah, I know what it means.
What does that integral thing mean? Antiderivative. And what is the antiderivative e to the u? So I get 1/4 e to the 4x plus a constant. I'm asking that you be able to determine that on your next test. You okay with that? Good. Now, in this next one, don't be misled. If it was simply just 1 over x, you would say that the antiderivative is natural log of x. So this is very similar. It's just that instead of x, you have a 3x plus 1. So if I say that u is equal to 3x plus 1, then du is equal to 3dx. I don't have a 3dx. Multiply by. So 1/3 du is equal to dx. So if I put the 1/3 and the du down, let's just look back at our integral to represent, what stays and what goes away. The substitution says that I get rid of the dx, okay, and then u is 3x plus 1, so u goes there. So what remains? 1 over u. Good. What is the antiderivative of 1 over u? Natural log. So we have 1/3 natural log of the absolute value of 3x plus 1 plus c. Letter C and letter D are very similar to the 2 we just did. I would like you to try those 2 on your own. Ready, set, go. Okay, let's see what you got. I chose u to be x cubed, and the reason why x cubed is an excellent choice because the derivative of x cubed is 3x squared. And notice how an x squared pops up right there, doesn't it? That's a sign that it's a good choice. So I multiply by 4 and I divide by 3, so you should have 4/3 du is equal to 4x squared dx. Notice how the 4 goes away and the x squared goes away and the dx goes away. And I'm left with 4/3 integral du. I have e to the u in its place. Now the problem is simple. The antiderivative e to the u is e to the u. So e to the x cubed, and then it's plus c. In this situation, don't let the 8 scare you. U is equal to 2x minus 9, and du is equal to 2 dx. Now, you could say I want a 1 dx, or you could say you want an 8 dx. It's going to work out either way. I chose to multiply by 4. So 4 du is equal to 8 dx. So therefore, I have a 4 out here, and I have a du here. So what remains? 1 over u. So the antiderivative of 1 over u is the natural log of, and we say 2x minus 9 plus c. What's different about letter E? You have bounds. That's the difference between a definite integral and an indefinite integral. Now, your numbers were what?
3.
Yeah, 8 to 3. Why is that a bad idea? Yeah, you get 0 on the bottom, right? So I made the problem. I didn't pick very good numbers. So we're going to switch it to 9 and 4, okay? So if I have a definite integral, I know I'm going to come up with a numerical result, So I'm going to say that u is equal to x minus 3. So du is equal to simply 1 dx. I would like to multiply by 2. 2 du is equal to 2 dx. So now I have the integral of 2 du, and what remains in its place? 1 over u. Antiderivative of 1 over u. So 2 natural log of absolute value of x minus 3. And we are going to now evaluate that at 9 and 4. Okay. Let's get a little tricky here. I plug in the 9. What do you get? Yep. Minus. Does anybody know what the natural log of 1 is? It is 0. Okay? Now, I want to show you something so that you can understand. This is a little bit of a review of logarithms. This is not how the answer will be expressed on the AP exam. It'll be 2 times the natural log of 6 minus the natural log of 1. Do you remember when you are subtracting 2 logarithms, how you can write it as 1 logarithm? Natural log of 6 over 1. You can switch your subtraction to division. You remember that? Okay, there's your reminder. What is 6 divided by 1? So you have 2 natural log of 6. Very likely that the answer would be written like that. A for the day if somebody could tell me a different way in which it could be written from here. Yep, good. Natural log of 36. Why? The 2 could also move up to an exponent in that situation. So those are those pieces. Do you remember those? Thank you for your honesty. All right, let's try one more, then we'll have you start working on some of your assignment, okay? What do you want to do here? What do you want to do? Good, excellent. U is equal to e to the x minus 1. So du is e to the x dx. So notice how my e to the x dx is taken care of right there. So now I have the integral du of what? 1 over u. Antiderivative of 1 over u. So I have the natural log of u, and u is e to the x minus 1. And I'm going to evaluate that at 4 and 2. So I have the natural log of e to the 4th minus 1 minus the natural log of e to the 2nd minus 1. What can you do if you're subtracting two logarithms? Write it as one divided by the other, correct? So this is not the way the answer would be expressed. They would go natural log of e to the 4th minus 1 over e to the 2nd minus 1. This is not how the answer would be expressed. Why? Because it factors. That's the difference of squares. Natural log of e squared minus 1 times e squared plus 1 over e squared minus 1. What happens? E squared minus 1's cancel, and so you're left with the natural log of e squared plus 1. Now, does anybody know why they would allow themselves to drop the absolute values at that point? Yeah, there's no way that e squared plus 1 is negative, is it? That's not negative. So that would be then written as the answer, okay? All right, we are not done, but you have at least enough to kind of get started, okay? So we'll go over the next set tomorrow. I'm going to point out the problems that you should start working on. No. No, you would not lose points. Safe bet is to put absolute value on the natural log results, yes. Right now, I'd try problems A, B, C, E, and F on the front. And on the back, A, B, C, and E. We have a couple more challenging problems to kind of introduce tomorrow before you're ready to the whole thing. But you have about 8 minutes to kind of give that a little bit of work. You should be ready to go.